Hello, my name is Brionna Colson-Fearon, and today I will be solving review question number 10 on page 525 of the textbook. The question asks, what is the dispersion force? What does the magnitude of the dispersion force depend on? And how can you predict the magnitude of the dispersion force for closely related elements or compounds? So this question is asking for a few different things, but we're going to take it step by step. The first question asks, what is the dispersion force? Dispersion forces are a type of intermolecular force. Other types of intermolecular forces include dipole-dipole interactions, hydrogen bonding interactions, and ion-dipole interactions. Dispersion forces are the weakest of the four. They are found in all molecules, but more specifically seen in those which are nonpolar, meaning their electrons are evenly distributed throughout the molecule. Dispersion forces create induced dipoles, which occur when there is a temporary uneven distribution of electrons throughout a molecule, causing one end to be more positive than the other. The second question asked is, what does the magnitude of the dispersion force depend on? The magnitude of dispersion forces depends on the size of an atom or molecule and the shape of a molecule. Molecules with a larger molar mass will have stronger forces. This table shows 6 noble gases, as well as their respective radii, molar masses, and boiling points. Because helium is the smallest atom, it will have the weakest dispersion forces. The magnitude of dispersion forces correlate with the boiling points of atoms or molecules. As you can see, helium also has the lowest boiling point, which is another indication of how weak its forces are. Another way to illustrate this would be to compare the strength of the forces between various types of alkanes. Alkanes are hydrocarbons where all of the atoms are connected by a single bond. The amount of carbons in which an alkane contains can be determined by its prefix. For example, propane has 3 carbons while octane has 8. You can also compare the strength of the dispersion forces between alkanes by looking at their sizes and boiling points. Propane would have weaker forces than octane because it has a smaller molar mass and a lower boiling point. The magnitude of the dispersion force is also dependent upon the shape of a molecule. For example, if you look at pentane, it has many constitutional isomers, meaning there are many different shapes it can take. The isomer which is more linear will have the strongest forces, while the isomer which is more circular will have the weakest forces. This is true for all molecules. The more linear the shape, the stronger the forces. The third question asks is, how can you predict the magnitude of the dispersion force for closely related elements or compounds? In order to do this, all you have to do is look at the size and shape of each molecule as I mentioned before. For example, imagine if you wanted to compare the magnitude of the dispersion forces between 2,3-dimethylbutane and heptane, which are 2 hydrocarbons. 2,3-dimethylbutane would have weaker dispersion forces because not only is it a smaller molecule, but it also is more circular than heptane. Thank you so much for watching, and I hope this was helpful.